Alright guys, this is the last homework assignment that I'll do with you on video before I see you again, which should be Monday. So here is our lesson 70 homework. We have 18 problems, 1 through 9, 14, and 15, 17, 20, 23, 24, and 28 through 30. Okay, let's tackle these one at a time. Here we go. Number 1 looks like a probability problem. 1, 2, and 3. Find the probability of the following events. Number 1, tossing a coin heads up or rolling a 3 with a number cube. All right, let's think through this. First of all, what is the probability of tossing a coin heads up? So we only have two total possible outcomes, right? And one of them is that we would roll heads or toss heads with a coin. So it says or, so that means we're going to add the probability of rolling a 3 with a number cube. Okay, rolling a 3 with a number cube. So for that, I've got 6 possible total outcomes, right? Because I've got 6 sides of the cube and one of them is a 3, so I have a 1 in 6 chance of doing that. But it's also possible that I could roll these two at the same time, right? These are inclusive events, so that they might happen at the same time. So I need to subtract out the probability that these two things happen at the same time. Now, in order to find that probability, I need to multiply them together. All right, it's a little bit tricky, but let's remember that from when we were talking about learning about probabilities, gosh, way earlier in the beginning of the year. So the probability of one times the other gives us a probability of both of them happening at the same time, which is a 1 in 12 chance. So I need to subtract out that chance that I might roll them at the same time. All right, to do this subtraction, I could honestly just do it in my calculator, or I can go ahead and make all of these denominators 12, because that's the least common multiple I've got here for all of these. So let's do that. If I make all 3 fractions 12ths, then I can do some simple calculations. That one's already a 12. So to make this one a 12, that becomes 6 12ths. This I multiplied by 2 to get 12, so this becomes 2. And I have 6 plus 2, which is 8 minus 1, gives me a total probability of 7 out of 12. So that is my answer. I have a 7 out of 12 chance of tossing a coin heads up or rolling a 3 with a number cube. Okay, number 2, tossing a coin tails up or rolling a number less than 4 on a number cube. So we're going to do this in a similar way. So the probability of tossing a coin tails up is a 1 in 2 chance, or means we're going to add probabilities together, or rolling a number less than 4. So that's a 3 in 6 chance, right? 3 in 6, which I'm just going to in my head say that's 1 in 2 because I just reduced it in my head, right? A 3 in 6 chance is the same as a 1 in 2 chance. And I need to subtract out the probability of these two things happening at the same time because they could. It's possible. So to find that probability, I multiply those two together and I get 1/4. So I'm going to subtract out 1/4. If I just think my way through this, 1/2 plus 1/2 is 1 minus 1/4 is 3/4. So I have a 3 in 4 chance of tossing a coin tails up or rolling a number less than 4 on a number cube. Okay, now number 3, tossing a coin tails up and rolling a number greater than 6 on a number cube. I'm so glad they gave us this one because there is no possibility that we can roll a number greater than 6 on a number cube, right? So I'll just write that. Rolling a number greater than 6 is impossible. In this where we have a number cube that only has 6 sides, right? Where each one is 1, 2, 3, 4, 5, 6, there is no 7. So I can't roll greater than 6, which makes it very easy that the probability of rolling a number greater than 6 with anything is 0. I have a 0% chance of rolling a number greater than 6. Doesn't matter what the other one is. Okay, great. Let's go on to number 4. Solve the inequality. Y minus 2 is less than 1/2. I want to get y by itself, so I'm going to move the 2 from this side of the inequality to this side and end up with y is less than 2.5. Okay, that's my answer. So I'll put that over here. Y is less than 2.5. Alrighty. And move on to number 5. Y plus 3/2 is less than 1/4. So I'm going to subtract 3/2 from this side to move it over to this side. Now I don't need to flip this inequality sign because I'm subtracting, not multiplying or dividing, right? So when I do this math, I will end up with y equals, let's see, 1/4, which is less than 3/2, which is 1.5, right? So this is negative 1.5, and if I add a 1/4 to that, then I'm going to end up with, oops, not equal to, is less than, the inequality stays the same, negative 1 and 1/4, or negative 5/4, either way is fine. Okay, y is less than negative 1.25. Great. Number 6, add 18 times the square root of 3y plus 8 times the square root of 3y. So I've got 18 packages of the square root of 3y and 8 of them here, which means I can add the coefficients together since the radicals are the same. So all I really need to be able to do is add 18 to 8, which is 26 of those square roots of 3y. That's it. 26, 3y. Alrighty, number 7. Did you love it when the radicals are the same? You just add them like that? Super cool. And that's what we have here too. I've got 1 square root of 3x plus 2 square roots of 3x, which means altogether I've got 3 of them, right? This has an implied 1 in front of it here, but this is one of these guys right here, so I've got 3 square roots of 3x. That's it. Flying. Okay, number 8. Write an inverse variation equation relating x and y when x equals 18 and y equals 4.5. Okay, an inverse variation means that it's going to end up in the form y equals k over x. Okay? We've been given x and y so we can solve for k, because our equation needs to have a value for k and just x and y as variables. So that means I need to find k. And the information that I have is that y equals 4.5. I don't know what k is yet, but I have x. X is 18. So if I multiply each side by 18, I'll get k over here by itself, and I end up with 18 times 4.5, which, if I stick that in my calculator, I could do that in my head, and I end up with 81. So this is the value for k. Okay, k equals 81, which means I'm going to put that back into this equation here and end up with y equals 81 over x. That's the equation. Okay, guys, that relates x and y in an inverse variation where x was, what was x again? 18? Yeah, and y was 4.5. Okay? All right, number 9. Determine if the inequality symbol needs to be reversed, then solve. All right, so we've got negative 2a is greater than or equal to negative 5. The inequality needs to be reversed if we multiply or divide by a negative number. And check this out. In order to get a positive a by itself, I'm going to have to divide by negative 2, right? So the answer first is yes, it does. Okay, it's going to need to be flipped because I'm multiplying by a negative number, and I'm going to end up with, once I solve this, this goes away and I've got a positive a. I'm going to switch that symbol, and negative 5 divided by negative 2 is just 5 halves, or 2.5. Either way is fine. Okay, but a is less than or equal to 5 halves. If you want to write it as a mixed number, 2.5, that is equally acceptable. Okay, let's go on to number 14. Great work, guys. Proud of you. Okay, turn the page. And number 14. Oh, we got another one of these decks to deal with. I'm going to draw a picture. Helps me see. Okay. All right, Jason. He's building a square deck around his home. Here's the home, here's the deck. His home is also in the shape of a square. How convenient. He wants the deck to be 9 feet wide. So he wants this right here, and we've got this picture in our book to be 9 feet. Around the outer edge of the house has a total side length of 8x. Write a special product and simplify to find the area, including the deck. So I know that each side, if it's 9 on this side, it's also 9 on this side, which means this whole thing from here to here is 8x, not plus 9, because I've got 9 on each side, but plus 18, right? So if I'm going to write a special product, then it's going to be 8x plus 18 squared. I already know when I've got a plus b squared that that's going to end up giving me a squared plus 2ab plus b squared. That's what I remember. This is my a term, this is my b term, right? So if I'm going to use this special product formula, or I could do this, honestly guys, I could just write out both of the binomials and I could use my normal FOIL, but let's just do this and use this special product here to help us remember that here's my a term. If I square it, okay, then I get 8 squared, which is 64 x squared, plus 2 times a times b. So what's 18 times 8x? It's 144x, and I need twice that much. So I need 144x times 2, which is 288x. You didn't see me do that on my calculator over here, but I did. Okay, so I did 8 times 18 to get my a times b. That was 144x, and I multiplied it by 2 and got 288x plus b squared. My b term is 18. I'm going to do that on my calculator too, because I don't know what 18 times 18 is off the top of my head. I should, if I had all my squares memorized, right? For those of you who do, you knew automatically, immediately, that it was 324. So here's the answer. It's this many feet squared. I'm just going to put a box around that rather than writing it all over again. Okay, number 15. Move my paper up. The length of a golden rectangle. Length equals x plus x times the square root of 5. If x equals square root of 5, what is the length of the golden rectangle? So what I'm going to do is I'm going to take this square root of 5 and I'm going to substitute it in every time I have x. Okay? So let's do that, and that's how I can simplify this. So I put square root of 5 in for this first x, square root of 5, plus I'm going to put square root of 5 in for x here, and I've got one more of them. Okay, cool. So what I need to see here is that this is the square root of 5 plus, remember my product rule for radicals tells me this is the square root of 5 times 5. Square root of 5 times the square root of 5 is the square root of 5 times 5. So I can simplify this then to the square root of 5 plus, because I've got 2 of them in here, I can pull one out and I end up with square root of 5 plus 5. That's the length, okay, of the golden rectangle. So let's put that over here. I guess I'll go like this. 14 here was the answer. For 15, the answer is the square root of 5 plus 5. Number 17. solve the following system using the elimination method. I love that method. So I've got negative 8x minus 5y equals negative 52. And then I've got 4x plus 3y equals 28. Okay, I see two ways using elimination that I could deal with this. One is I can multiply this entire thing by 2, because then I'll have negative 8x and I'll have 8x, so those will cancel each other out. Or I can multiply this, well, I can multiply this by 5 and this one by 3, so that these are both become 15s. I'm going to choose the easier way, okay? And just multiply this whole entire thing by 2, so I save myself a step. That means I can leave this one alone. Negative 8x minus 5y equals negative 52. And I need to do all of this math. So 2 times 4x is 8x. 2 times plus 3y is plus 6y equals 2 times 28, which is going to give me 56. Okay, now I get to combine. This goes away. Negative 8x plus 8x is no x's. Negative 5y plus 6y is just a single y. Ooh, that's nice. And I've got a positive 56 and a negative 52, which leaves me 4 altogether. Cool. Easy enough. I only have half an answer, right? My answer needs to be in the form of an ordered pair, and I've got the y value. Now I need to find x. So I'm going to take 4 and put it back. I'm going to put it back into the original equation just in case I made any mistakes here. And I have negative 8x minus 5 times 4 equals negative 52. Negative 8x minus 20 equals negative 52. Add 20 to this side and this side, because we're just moving terms, and I get negative 8x equals negative 32. When I divide by negative 8, I get x equals 4. So my ordered pair is 4, 4. Of course, I could go and I could check that by putting both values in to see if it is a true statement. You could trust me for today that it is, but I would again recommend that you do that on your test to make sure that you didn't make any errors in calculations. Okay, number 20. Which of the following systems has only one common solution? Okay, we've got to do a little bit of reasoning here. I know I've just got a blank paper in front of me, but hopefully you can see your book. We've got to choose between scenario A, B, C, and D. In scenario A, I can see immediately that that's it. Okay, but let me just eliminate the other ones to be sure. For letter B, 5x minus 2y equals 0, negative, and then the second equation is 5 half x minus y equals 0. All right, you guys, listen, I can see that if I multiply that bottom equation by 2, I'm going to get 5x minus 2y equals 0. See that? So that means that there isn't only one common solution. There are infinite solutions because they're the same line. They're the same equation. How about letter C? Okay, I can see with letter C, that top equation, negative y equals 13x minus 6. And the bottom equation, negative 2y equals 26x plus 9. That if I were to divide that bottom equation by 2, see this? Then I'd end up with negative y equals 13x. See that, guys? So if they have the same slope, that means they're parallel lines. So I know it's not letter C. If I look at letter D, x minus 7y equals 14, and then this bottom equation, 1/4 x minus 7/4 y equals 7/2. If I multiplied that bottom equation by 4, I would get x minus 7y equals 14, right? Because if I multiply that by 4, then I'll end up with 7 times 2, which is 14. So that's the same line. So it's not that. That has infinitely many solutions. So the only possible answer is A. Y equals 21x plus 6 and y equals negative 7x. If I graphed both of these lines, they would have one point of intersection. Okay? All right. And I just did that kind of by process of elimination, that the answer for number 20 is A. All right, let's go on to 23. In fantasy football, Virtual teams are built by choosing from a pool of real players. In one pool of players, 72 play defense, 65 play offense, 8 play both, and 27 are special teams. If at least one player must be chosen at random, what is the probability that the player will be either offense or special teams? Okay, so first thing we need to get the total number of possible outcomes, right? So the total number of players. So I've got 72 playing defense plus 65 playing offense, 8 playing both. I'm going to assume that this 8 is not included in these. So I'm going to add that in there. And then 27 that are on special teams. When I add all of those up, I'm going to use my calculator to do that. 72 plus 65 plus 8 plus 27, I get 172. So there's 172 players. Okay? 172 real players to choose from. And one is chosen. What's the probability the player will either play offense? So I was told that 65 play offense, or special teams, which is 27, but I also was told that 8 play both offense and defense, so there's 8 more players that are playing offense, and that's what it's asking me, right? Anybody who plays offense in any form or special teams. So if I add those up, I get 65 plus 27 plus 8 other possibilities is 100. So there's a 100 in 172 chance that the player will play on offense or special teams, because I added those together. I added offense, special teams, and the both, right? To get all of them all together. Now, it looks like I can reduce this. If I reduce it by a factor of 4, I end up with 25, because 100 divided by 25, 100 divided by 4 is 25. 172 divided by 4 is 43. So I end up with a 25 in 43 chance. Just a few more problems left, and then we will be done with the homework for lesson 70. So we're going to move on now to number 24. Okay, here we go. One side of a square measures 2 times the square root of 9 meters. What is its perimeter? Okay, so I've got, for this, 4 of these sides. First things first though, can I simplify this? Can I simplify 2 times the square root of 9? You bet I can. I already know what the square root of 9 is, because 3 times 3 is 9, right? So this is the same as the square root of 2 times 3 squared. And because it is, I can pull that 3 out and make this 2 times 3, right guys? 2 times 3, which means one side is equal to 6 meters. It's asking me for the perimeter, so I know that I've got 4 sides, 6 plus 6 plus 6 plus 6, or 6 times 4, either one, which is going to give me a total of 24 meters. That's the perimeter, okay, of my square. Great. Number 28. 28, 29, and 30, and we'll call it good for today. Explain in your own words how to solve the inequality -2/5 g is less than or equal to 6. So I'm just going to write words here, okay, that say what I'm doing, that describe what I'm doing. So for 28, I'm not going to write it over here because it's going to take up too much room, so I'm going to write it over here. I will, I'm trying to get g by itself, so I will multiply by, and I want g to be positive, so I need to multiply by -5/2. Okay, I should have said I will multiply both sides, right, by -5/2. Then I will reverse the inequality sign because I multiplied by a negative number, right? So if I multiply, I'll reverse the inequality sign. If I multiply by a negative number, I have to reverse that inequality sign. That's what I'll do. 2 more problems to go. Number 29, Kyle wants to spend at most $100 for birthday presents. for the other 4 members of his family this year. He plans to spend the same amount on each person. Write and solve an inequality to represent the situation. What restrictions exist on the solution set? Okay, so he's got 4 people in his family. He wants to spend at most, so no more than, but it could be equal to $100, and he wants to spend the same. He's got 4 family members. He wants to spend the same amount on each one. So he's got 4, I don't know, I'm going to say S for siblings. I'm going to make them siblings, okay? So he's got 4 siblings that he needs to buy for, and he at the most, so he wants to spend no more than $100. So whatever 4 times however much the present is for each sibling needs to be less than or equal to 100. Now I can simplify this a bit, right? By dividing each side by 4, and I end up with S, the price for each sibling needs to be less than or equal to $25. So that's the first part of my answer. Okay, I'm going to put a box around that. That's the first part of my answer. The second part is kind of weird, honestly, the way they're asking it, but what restrictions exist on it? We're going to answer this because of what we know about money. Okay, so we know that the solutions, or the price for each gift, is what that means, must be between $0 and $25. Now the reason we have to say that is because what I've got in my inequality is that S can be anything less than $25. However, it's impossible for Kyle to spend negative dollars on a person unless he's really good with coupons, right? Okay, so reasonably, each gift is going to be between $0 and $25, and we know the other limitation is that each solution, meaning each price of the gift, right, will be a rational number. It's not going to be irrational because money can't be, well, I mean, you know, philosophically it can, but mathematically money has to be rational. Rational numbers rounded to the hundredths place, because that's how money works. We don't have anything less than a penny, right? Which is 1/100th of a dollar. So it's got to be rounded to the 100th place. Okay. 100ths place. Last problem. Number 30. Mariana can afford to buy at most 20 pounds of ground turkey. Write and solve an inequality to determine the number of burgers she can make if each patty uses 1/3 pound of ground turkey. Now, let's not talk ethically about whether or not Mariana should be using turkey to make burgers, but we'll just go with it, okay? Okay, here we go. So if she uses 1/3 pound for every burger, so 1/3 pound times however many burgers, and we know that whatever that is has to be less than or equal to 20 pounds. That's my equation. Okay, so each burger is 1/3 pound, and however many, we don't know what B is yet, but we know that however many burgers she makes are each 1/3 pound, and it's got to, in total, be less than or equal to 20 pounds. So the question that we're being asked now is, how many burgers can she make? All right, so let's go ahead and solve this inequality, which if we do that, I'm going to put a box around this one, because that's part of my answer. Okay, I'm going to rewrite it here and solve it. So if I want to get B by itself, I'll multiply both sides by 3 so that I get B on this side. Has to be less than or equal to 20 times 3, which is 60 burgers. So the most number of burgers that Mariana can possibly make out of her ground turkey is 60. Okay. All right, guys, that is it for today. Hopefully you're finishing this up on Friday, and I look forward to seeing you again on Monday, and we're going to do a test review and get ready for your cumulative test 13, but we'll do that review together in class, and I look forward to seeing you then.